This video we're going to be going over another type of powerful microscope for the class I'm taking from the notes. So, we are going to be talking about the extremely powerful electron microscope, and it's very similar to light microscopy. So, last time we had that little artist rendition of a light microscope, kind of looks something like this. We have the ocular lens, we have the objectives, we have the stage, and then, a condenser, a light source, as well as the arm. And then we also have those adjuster knobs here for fine and macro focusing. So, an electron microscope does have a lot of similarities to our light microscope. However, instead of using light, hence the name electron microscopes, are actually going to be using an electromagnetic lens, some electrons instead of, light, and then a fluorescent screen. We're using a fluorescent screen to view our images from the electron microscope because if we were just using our eyeball, let me just draw a random eye, all those electrons would damage that. That would be really bad for our eye, so that's why we're using a fluorescent screen. And then the wavelength of the electron is about 1,000 times shorter than light's. So that means we're able to magnify images to 100,000 times their actual size. In order to achieve this, there must be a vacuum because we don't want any of these electrons escaping out as we saw earlier here. So we'll have a vacuum. The microscope itself is extremely large and expensive. You need to be making a lot of money on Twitch or on YouTube in order to afford one of these. And it has a very complex specimen preparation. You're going to have to do all these different steps in order to see the images and the specimens at 100,000 times in the electron microscope. Alright, we have two types. We have the TEM, also known as the transmission electron microscope. So the beam of electrons will pass through or scatter. So we're just going to write that out. And this again depends on the density of the region. So dark areas such as maybe the nucleoid region of this bacterium will be darker compared to the less dense areas of the extracellular material. There's going to be thin sectioning to see the internal details. And then another type that you could use with TEM, another type of observation, would be freeze fracturing. And then this is kind of like etching the image of whatever you're looking at. And then to reveal the shape of these internal structures, you're just going to look at that etching, get a better idea of what it looks like inside. Alright, the next type we have is the scanning electron microscope. So this is supposed to be used for surface details. And then this is where our complex preparation comes in. So first you're going to take a surface and then you're going to coat it in all of this metal. So let's say we have our sample there. We're coating it with a thin film of metal. Next, we're going to use a beam of electrons. So here's my beam of electrons. And they're going to scan across the surface. So I'm just going to go like that. So those are our electrons scanning. And then the electrons that are released from the specimen are going to be observed for a 3D effect. So you might see a 3D effect of this extremely small molecule or bacterium like that. So there we go, our 3D effect is created. We also have scanning probe, so SPEM. Scanning probes are also known as the atomic force microscope. And there isn't any special prep. However, these will allow you to see like a topographical map. So there's going to be bumps because there's this probe that will move across a sample surface, and then it will feel the bumps and the valleys of atoms, and then it'll give you a surface map. So, surface map. And that's all on the electron microscopes. Please do something nice for someone. Have a good one.